Bismillahirrahmanirrahim. Assalamu alaikum, dear students from Pakistan School Salala. Mr. Zaram Shahed says you welcome for your video lessons. Staying at home, studying well is nowadays your hobby. So please enjoy your lessons, video lessons, and do your work on time and send your assignment on time. Today our topic is atoms, molecules, and chemical formula. As you can see that it's a big display over here before you of the periodic table. In periodic table there are many atoms. These atoms now we will see. You have learned their elements. You have learned their symbols, name of few important elements in the periodic table in the brief introduction of that topic. Now we will see how these atoms they make molecules and how can we write their chemical formula. Yes, dear students, we have to see our first topic, that is elements. So elements are pure substances and they have only one kind of atoms. As in your periodic table you have seen 92 elements starting from helium, lithium, beryllium, boron, nitrogen, fluorine, neon, sodium, magnesium, aluminium, phosphorus, sulfur, chlorine, argon, potassium, calcium, scandium, titanium, vanadium, manganese, chromium, iron, cobalt, nickel, zinc, gallium, germanium, arsenic, selenium, bromine, krypton. So you can see these all elements, 92 elements have 92 kinds of atoms. So all elements, they have different states. You have seen some kept in the bottle, some kept in the metallic state, some in the liquid form, some into the gaseous form, some powder form. They all have their own natural appearance because they are found all in nature. So dear students, you have to, I'm giving you this review to you to memorize the symbol with their name. So try to memorize the symbol writing for the elements. And now you came to know that elements only contain one kind of atom. As you can see there, the sample having big sample. So big sample can have trillion, million and many trillion of atoms. So one sample of one element contain million of one kind of atoms, to remember. As you have seen many elements before in the previous slide, now you are looking here few examples that we will discuss. Hydrogen. As you can see, I have given some small atoms, and hydrogen atoms, you can see they are disappearing because hydrogen is a colorless gas and all the molecules, they are colorless, so we cannot see them. So next is carbon, having metallic form, oxygen again gas, silicon element, you can see atom are like metallic shape and then they are solid shape and they are used in the computer chip. Copper, you can see all atoms, it's a metal and it have shiny appearance and it will be giving you it is used in the wires. So you can see all elements, they have one kind of atom among them, and I have given you some examples over here. So elements are the substances made up of only one kind of atom, and these are pure substances. And if you see carbon, the substance carbon, it have million trillion of carbon atoms in this. So a substance carbon have million trillions of carbon atom. Hopefully you can understand definition of element with few examples, with their symbols, with their names, with their appearance and their uses as well. So dear students, here now another term you have to see, that is molecule. So molecules are combination of elements. Two or more elements joined together, they form a molecule. You can understand with the given videos over here. You can see I have given you some elements again: hydrogen, carbon, oxygen, silicon and copper. So you can see they are joined together in groups. Here you can see their color. Hydrogen is almost white, carbon is blackish color, oxygen I have represented with red color, silicon gray and copper with golden color. So you can see they are grouped together over here like a compound, like a molecule form over here. Different combination you can see over here. Now if what happens if we are going to separate them? If I'm going to take out all the hydrogen and I'm going to gather here, so this is all atoms of hydrogen here. Carbon are going towards carbon element, and red moving towards oxygen element, this going to the silicon, and then there is a copper. So dear students, you have seen that elements, they if they join together they make up molecules, and if they different combination and if they are separately, they are only one kind of element, one kind of atom. Element have one kind of atom only, and if they join to form a molecule, they can be have one kind and they can be have two kinds. We can also see with other examples. Okay dear students, today we have to see our next definition, that is types of molecules. So types of molecules, when atom they join together they make up molecules. So our first type is molecules of elements. If atoms they join together having one kind of atom, they will be termed as molecules of element, because element before also we have studied that element have they one kind of atoms. So in molecules of elements, they have only one kind of atoms joined together chemically in fixed ratio. Fixed ratio means that they have if we talk about example, like you can see there is a model of hydrogen. So there are two hydrogen atoms. So formula for hydrogen gas is H2. And next example is oxygen. Oxygen gas. Oxygen gas have again two atoms of oxygen in it. So their number is fixed in any formula. So and they are joined chemically. So molecules of elements have one kind of atoms joined together chemically. Let's see another example, number 2, that is molecules of compounds. Molecules of compounds have two or more different kinds of atoms. Only difference is over here. So molecules of compounds, they have two different kinds of atoms joined together chemically in a fixed ratio. For example, carbon dioxide and water. So here you can see models of water over here before you. So now we see different atoms like carbon, hydrogen and oxygen. These are atoms. So how they make up the molecules, let's have some example. So our first example is like H2, hydrogen gas. So it is a molecule. Our second example is oxygen, O2, and these two are molecules of elements. Now our third example is carbon dioxide. It have one carbon and two oxygen. It is an example of molecule of compound. Dear students, how can we represent our molecules? So molecules, they can have three kinds of representation. As you can see here, they can be represented by atomic structures. If I look up here, models, and then chemical formulas. So if I take example of carbon dioxide, so atomic structure can be written like that. It's its model form, and this model form, this is chemical formula of carbon dioxide, CO2. And then there is water. This is its atomic structure, this is its model of water. These atoms are represented as a model and stick form, and then there is chemical formula of water, that is H2O. So it's an example of representation of molecules. One interesting effect about molecule is that if we talk about that all elements form molecules, that is except noble gases. Noble gases are member of H group, and they want to live in their atomic state, so they don't have any combination of molecules of elements or molecules of compound. Let's have a look of noble gases. They are also called as inert gases. They exist independently. They do not join chemically to form molecule. Members of noble gases or group 18 are before you: helium, neon, argon, krypton, xenon, radon, and all these elements, they are all member of group 8 or 18, and member of they are also called as inert gases. They don't want to join with any other atom or among themselves as well to form compounds, either molecule of compound or a molecule of atom. They stay independently. So our next description was chemical formula. Chemical formula tells us number and kind of atoms a molecule contain. A formula is written as the chemical symbol of the element followed by a number which tells you the number of atoms. A molecule of hydrogen have two hydrogen atoms joined together. Therefore, the formula of hydrogen gas is H2. If you think about that H2, it gives you symbol and it gives you number, and its number is fixed. H2 is the formula for chemical formula of hydrogen gas. A molecule of carbon dioxide have one carbon dioxide and one carbon and two oxygen joined together. Therefore, its formula is CO2, C1 and O2. So this is an activity. You can count atoms as well. So please do, students, do remember the chemical formula tells you number and kind of atoms a molecule contains. Dear students, there is an activity for you: counting atoms in a formula. Chemical formula, you know that they have fixed amount of atoms in that. So we will see some examples of like ammonia and methane. So let's see their number of atoms. If we see number of atoms of ammonia, it have one nitrogen and one is not written in the formula. As you can see, NH3 is written for ammonia. So N single, one nitrogen atom, and then there are three hydrogen atoms. And then we have to see another formula, that is methane. Methane have got one carbon and how many hydrogen? Yes, 4 hydrogen atoms. So this is an activity. I also have given some examples in your assignment, so please do them accordingly. Only you need to count atoms. So for writing chemical formula for certain compounds, we have a molecule of compound, especially we have certain rules that we have to follow. So for ionic compound, if they are ionic, we will first write their cation. Cation are positive charges. Then we will write anion. Anion are negative charges. Then we are going to put some across so as to assign charges as the subscript of other atom. This gives the atom a fixed number. You can see, you can understand this term by this. If we write formula magnesium, it's ion on the top plus 2, bromine, it's ion on the top minus 1. So bromine, when gets minus 1, its name become bromide. So what I do is I'm going to cross like a cross. I'm going to write its charge as the subscript over here. Its charge subscript over here. One, there is either positive or negative, no need to mention here. So this positive I'm going to mention here, it becomes Br2 rho, so its charge become the subscript of this. So in this way we can develop a chemical formula for certain compounds like ionic compounds as well. So you can see that there is an example of sodium chloride. Again, I'm going to write their charges first. Both have similar charges. Sodium and chloride have similar charges. So when I put a cross for their charges to write them as a subscript, there is nothing to write because their charges, equal charges, they cancel each other. So my formula becomes sodium chloride. You can also understand in another example. Here again example comes where their charges are unequal. That is example, sodium has plus 1 charge, oxygen have minus 2 charge. So if I'm going to put a cross to write a subscript, so I got 2 of oxygen here as a subscript of sodium. So I got Na2O, the chemical formula of sodium oxide. Chemical formula of calcium oxide is calcium charge plus 2, oxygen charge minus 2. Both have similar charges and so they cancel each other, and the formula of calcium oxide. Another example is aluminum oxide, in which aluminium charge is plus 3, oxygen is minus 2. If I write across, I got a formula Al2O3. So in this way we can write chemical formula. Last example is calcium sulfide. Calcium and sulfide both have equal charges, so you can see that their formula need nothing in the subscript side. So chemical formula of the cation anion having similar charges have simply their symbols. Students, let's have a recap. Today we studied about chemical formula, its example molecule, its example molecule of element and molecule of compound. We have studied element and the basic unit, atom. Hopefully you are doing well with the video lessons. Please give them prime importance. Do learn your lessons, video lessons, as well as your Zoom classes, and do your practice. Give an assignment to you on time and submit in the Google class. Thank you very much. Allah Hafiz.